Welcome to Standard of Math's problem of the week. For this week's problem, we're given a non-negative integer n, and we have a function f of n that gives us back the largest proper divisor of n. So it's not n, but it's still a divisor of n and the largest divisor. And we want to find all n, so n plus f of n is a power of 10. So we can rephrase this problem a little bit. So we can think of f of n as n over p, where p is the smallest prime divisor of n. So that will give us the largest possible proper divisor of n. And then n plus f of n is n plus n over p, which is n times p plus 1 over p, which equals 10 to the k. Note that p plus 1 and p are relatively prime, so whatever factors in p, we want p plus 1 to just only have factors of 2 and 5 in it. So we can write p equals 2 to the a times 5 to b minus 1. Note if a and b equal each other, this is 10 to some power minus 1, which is divisible by 9. So that doesn't work because we want p to be a prime, for this to be the largest possible proper divisor. Note that if we have both 2 and 5s here, then p plus 1 is 2 to the a, 5 to the b, and we're going to want n to have some factors of either 2 or 5, so that we have the same amount of divisors of 2 and 5 on the left side, because we want 10 to the k. 10 to the k has the same amount of 2s and 5s in it. But if n has 2 or 5 in it, then the smallest divisor of n will be 2, 3, or 5. But if we have at least, would be at least 10 times something minus 1, which would be greater than 5, which contradicts p being the lowest prime of n. So really we want p equal 5 to the b minus 1 or 2 to the b minus 1, but this is divisible by 4, which is not prime, so we want p equals 2 to some power minus 1. And so since this will become 2 to some power, we want n to have a factor of 5 in it. So that means the lowest prime divisor must be really less than 5. And so note this equals 1 is one that's the not proper divisor and not prime. That doesn't work. 2 to the 2 minus 1 is 3. So really p must equal 3. So we have So really plugging in p equals 3 in our original thing here, we get 2 to the 2 times n over 3 equals 10 to the k. If n has a divisor of 2, this would contradict 3 being the lowest prime. So our lowest prime is 3. N must have at least 2 5s in it and 1 3 for this to become a power of 10. So n must equal 5 squared times 3, which is 75. And this is our only solution. Thanks for watching. Please check out standardmath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.